In section 14.5, you are going to learn 3 special cases that will make sum factoring problems easier to work. The first case is when you have a difference of squares. In other words, if you have something squared, we'll call it A, and then it's subtracted, and then you have something else squared. That is the difference of squares. And the factoring for that is A plus B times A minus B. An example of that is x squared minus 4 squared. So that's going to be x plus 4 times x minus 4. And that's how you factor a difference of squares. The other 2 special cases have to do when you have perfect square trinomials. And perfect square trinomials have this formula. If you have a squared plus 2 times a times b plus b squared, you can factor that to be a plus b squared. And then the other formula is if you have a squared minus 2ab plus b squared, that's going to equal a minus b squared. So these 2 formulas need to be memorized, and so here's an example where you might see one of those and put it to use. Here you have x squared plus 10x plus 25. What you want to do is you want to see if your first and third terms are perfect squares. The first one is, it's x squared, that's perfect square of x. The second one is the same thing as 5 squared, so it's a perfect square of 5. The next thing you want to do is you want to see if this middle term is the multiplication of this square root and this square root, and also times 2. So, in other words, let me back up. In this case, if you compare this with this, well, let's do this one because we're dealing with pluses. With this one, you're saying that A corresponds to X. So let's write that. A equals X. And B corresponds to 5. So we're going to write B equals 5. But before we know that this is a perfect square trinomial, we have to see if 10x corresponds with 2ab. So what is 2ab? So let's do it over here. 2 times a times b is going to be 2 times, well, a is x and b is 5. And we have 2 times 5, and that's 10x. Sorry about that. So if you'll notice, this is 10x, so it corresponds with 2ab. So that means that we can go back to this problem, x squared plus 10x plus 25, and simply write down that it factors to x plus 5 squared, because a squared plus 2ab plus b squared gives you a plus b squared. So the key to using this formula is to notice, is this a perfect square? Is this a perfect square? And so when you take 2 times x times 5, does it give you the middle term? Okay, so with that information as an introduction, I want to look over the class notes. Alright, here are the class notes for 14.5, where we're dealing with special factoring techniques. And the special factoring techniques are that when you have the difference of squares, it's going to factor out by adding and then subtracting. So for instance, in this case, we're going to work it backwards. We're going to say if we start with an x plus 5 and an x minus 5 and multiply them together, the theory is we're going to get x squared minus 5 squared. So let's see if that's true. When we FOIL it, we get x squared plus 5x plus 5x, minus 5x minus 5 squared. I'm just going to leave it as 5 squared. And that's going to be x squared, and the plus 5x and the minus 5x cancel, minus 5 squared. So you have x is a equals x, and b equals 5. So what we're saying here is the formula is a squared minus b squared equals a plus b times a minus b, and we've just worked that backwards. Here we have a squared minus b squared, which is a plus b times a minus b, where a is x in this case and b is 5. So if we FOIL this term, we should get a squared minus b squared. So our answer should be x squared minus 12 squared, and when we actually write it, we need to write it like that, because 12 squared is 144. So let's check that. When you FOIL x minus 12 times x plus 12, you take the first terms, you take the outer terms, the inner terms, and then the last terms. And then the outer and inner terms cancel, so we're left with x squared minus 12 squared. So the point of all of that was just to show you that this formula is true. A squared minus b squared equals a plus b times a minus b. Now notice in this formula your equation has to have 2 terms, not 3, and it has to be a difference, a subtraction. So for instance, if you had x squared minus 16, you could use this formula. But if you had x squared plus 2x minus 5, that would be 3 terms. You couldn't use this formula. And if you had x squared plus 16, that would be the sum of squares, and you could not use that formula. Okay, when you're looking at using this formula, you have to be able to identify perfect squares. So it's important that you memorize the common ones. So here are just numbers counting from 1 to 13. 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on until you get to 13 squared is 169. If you know your multiplication tables, you know this up to 10. You should know it really up to 15. 11 squared is 121, so it looks like 11 with the 2 in the middle. 12 squared is 144. 13 squared is 169. 14 squared is 196. You just switch these around. And 15 squared is 225. Okay, so if you're going to factor these using that formula, it's really quite simple. You have x squared minus 49, so you ask yourself, is 49 a perfect square? And you can look on this table and see there's 49 right there, and it's the perfect square of 7 squared. So you can rewrite this as x squared minus 7 squared, and then you use this formula, whoops, didn't mean a, meant x. Use this formula, x plus 7 times x minus 7, because x squared minus 7 squared factors to x plus 7 times x minus 7. So you're going to be using this difference of squares formula throughout 310. It's a very important formula to memorize. Okay, so let me write down again what the formula is. If you have a difference of squares, they factor to a plus b times a minus b. So let's do another example. Go ahead and pause the video and work this problem, and then come back and see if you did it correctly. Y squared minus m squared. Y corresponds to a and m corresponds to b. So all we have to do is write out the answer. It's going to be y plus m times y minus m. On the last one we have z squared minus 9/16. And we need to ask, is 9/16 a perfect square? The way you ask that is you look at the numerator and say, is 9 a perfect square? Well, here's 9. It's a perfect square of 3. Is 16 a perfect square? Here's 16. It's the perfect square of 4. So let's rewrite this as z squared minus 3 squared, because that's 9, over 4 squared, because that's 16. And if you remember from your exponent rules, that's equal to z squared minus 3/4, all of that squared. So if the numerator and the denominator have the same power, then you can just write the fraction and give it the same power. Now we have in the form of a squared minus b squared. 3/4 is b. So that means we can simply write out the answer, z plus 3/4 times z minus 3/4. So see how easy that is once you get to this point to use this formula. And in fact, you have not been taught another way to factor that problem, so you really need to have this memorized. And you can go ahead and FOIL it to check that it's correct. So go ahead and work these problems on page 2 using that formula, and that will give you a lot of practice at it, and then come check your work. Alright, I hope you've taken a stab at these. Let's look at the first one. We've talked about if you have a difference of perfect squares, but what if this number is not a perfect square? 8 is not a perfect square. If you look on page 1 in your chart, you will not find 8 anywhere listed with the perfect squares. So that means you cannot use that formula on this, and this is called a prime polynomial. It means it cannot be factored any further. On the second one, you also have a prime factor, or prime polynomial. Do you know why? It's because you don't have a difference, you have a sum. So sum of squares, that formula doesn't work. It has to be a minus sign here, a difference of squares. In the next problem, we are used to having m squared minus 16, but we're not used to having 25m squared minus 16. So the question to ask is 25 a perfect square? And it is. It is 5 squared. So we just rewrite that, and 16 is 4 squared. Now remember from your exponent rules, 5 squared times m squared is the same thing as 5m, all of that squared. So now you have an a squared minus b squared situation where a is 5m and b is 4. So you can just write down that that equals 5m plus 4 times 5m minus 4. In the next case, you have a negative in front of your 49, and you have a sum here. But what you want to do is see if you can redo this by and get a minus sign there. So when you have opposite signs here, you will be able to find a difference. And the way you do that is that you take the opposite of this expression, so that would be as if you're multiplying everything by -1. So -1 times -49 is 49. and negative 1 times 64 makes that a minus 64. But you have to put a negative out in front because you've just multiplied everything by negative 1, so you have to pull, that's like pulling out a common factor. And you can check that by distributing that negative sign. Negative times 49z squared gives you negative 49z squared. Negative times negative 64 gives you positive 64. So now inside the parentheses you have a difference of squares. So let's rewrite that. To show that, you have negative bracket, and then you have 7z squared minus 8 squared. So A is 7z and B is 8. So that gives you 7z plus 8 inside the brackets, 7z minus 8. But then you still have that negative sign out in front here. So after you finish factoring this, you get this, and then you bring over your negative sign. This next problem is easier. You just have 3x squared minus 2z squared. I'll write this in blue so we can distinguish it. So that's going to be equal to 3x plus 2z times 3x minus 2z. I'm going to partition that off. Okay, and then in the next one we have p to the fourth. But what is p to the fourth? We want something squared. So if you divide the exponent by 2, you get p squared squared. So to simplify p squared squared, you multiply the exponents and you get p to the fourth. So you can see that this is the same thing as this. But it gives us something squared, and that's what we're looking for. And then we have minus 6 squared. So this is going to equal p squared plus 6, because a is p squared minus 6. And so that's going to be our final answer. You should always ask yourself when you do this, can I factor this? And the answer is no, because it's a sum. And can I factor this? And the answer is no, because 6 is not a perfect square. If 6 were a perfect square, you'd have to factor this using the same formula. Alright, I've moved things around to give us a little more space. So now you try m to the fourth minus 16. Pause the video and try that. So I hope you got m squared plus 4 and m squared minus 4, but if you listen to what I just said, you'll see you have to check. Is this factorable? No, because it has a plus. Is this factorable? Well, it has a difference. Is this a perfect square? Yes, 4 is a perfect square, so we can rewrite that as m squared plus 4 times m squared minus 2 squared, which is m squared plus 4 times m plus 2, m minus 2. And that is the final answer. Okay, in the next one, we have 50 and 2, and neither of those are perfect squares, but they both have the common factor of 2. So let's see what happens when we pull out the greatest common factor. Okay, now we have 25 in our first term and b squared in our second. 25 is a perfect square, but we've got this c. We should have pulled the c out as well, so let's go ahead and rewrite it using that. And now we have 2c times the difference of squares. Let's rewrite it as the difference of squares. And so now we can use our formula and say this is 5a plus b times 5a minus b. And then that is our simplified answer. I want to give a lot of room for this next one. We have d cubed minus 3d squared plus, minus 9d plus 27. When you have four terms like that, think grouping. You want to do grouping. But our problem is we have a minus here, and we need to change that to a plus in order to do our grouping correctly and not mess up on our negatives. So to change that to a plus, we change the sign of the 9d to a negative 9d, and we add a line to the minus sign to make it a plus sign. So now we have d cubed minus 3d squared plus negative 9d plus 27. And we can group. So when we group, we need a plus in the middle, and then we can group the rest of the terms. Now we look for common factors within each group, and in the first case we can pull out a d squared, and that gives us a d minus 3 plus, and then we can pull out a negative 9, and that gives us d minus 3. And the way I got that is I know I wanted to end up with d minus 3, so I had to pull out a negative 9. So I say, okay, divide both of these by negative 9 and put the negative 9 in front, and you're left with positive d minus 3. Now I have my d minus 3 terms the same, so I can again pull out greatest common factor, which in this case is d minus 3, and what we have left is d squared plus negative 9, which is minus 9. So then I see, well, this is a difference of squares, so I can rewrite it as d minus 3 times d squared minus 3 squared, and now I can apply my formula to this part, which is a difference of squares, and I get d minus 3 times d plus 3 times d minus 3. And you can leave it like that. That's a fine final answer. Or if you notice that the d minus 3's are the same, you can rewrite it as d minus 3 squared times d plus 3. But either version is a correct answer. So we've just exhaustively looked at the difference of squares. Now we're going to look at perfect square trinomials, and what that is if you have a squared plus 2ab plus b squared, it equals a plus b, all of that squared. Similarly, if you have a squared minus 2ab plus b squared, it's a minus b squared. So what you need to notice is if you have a perfect square here, a perfect square here, a plus here, and either a plus or minus here, you're going to be able to use one of these formulas. The middle term, though, needs to be twice the product of a and b, or else it won't work. So for instance, here you have x squared plus 10x plus 25, which we actually did earlier. A is x, b is 5, because 25 is 5 squared. So our b squared is 5 squared. And 2 times a times b is 2 times a is x times b is 5. so it's going to be 10x. This is 10x, so it works. We can check that because our middle term is 2ab. So that means that x squared plus 10x plus 25 factors to be a plus b squared, or in this case x plus 5, all of that squared. In the second case, we have a minus sign to start with, but a plus sign at the end, so that's okay. Perfect square, perfect square. If you look on your chart on page 1, you see that 121 is the same as 11 squared. So we need to know if 2 times x times 11 equals 22, and it does. 22x, and it does. So we can rewrite this here as x minus 11 squared according to this formula. Here we have the same thing, only here we have 3m, and 3m, all of that squared, and here we have 4 squared. So we have perfect squares. We need to ask, does this equal 2 times 3m times 4? So here's 3m and 4. 2 times 3m times 4 equals 24m, which is this middle term, so it checks. And we have a minus here and a plus here, so that's okay. We can use this formula. So a is 3m, b is 4, and we don't need to worry about that anymore now that we've checked. So we can just write 3m minus 4, because it had this minus sign here, squared, and that's the solution. And this one, we have 5y, all of that squared, and 4 squared. 2 times 5y times 4 gives us 40y. But our middle term is 20. And I said y, but it should have been y here. But anyway, it says 20y, so it won't work because it should have said 40y. So it's not a perfect square trinomial, and I'm going to change this to y. Okay, so we can't use that formula. And since it isn't a perfect square trinomial, even though this is a perfect square and this is a perfect square, then it's going to be a prime polynomial. Prime means it cannot be factored any further. Okay, in the next case, we have 12z to the third, 60z squared, and 75z. So we can factor out the common factor 3z. 12z cubed divided by 3z is 4z squared. 60z squared divided by 3z is 20z. 75z divided by 3z is 25. So now we have this, and we need to see if this is a perfect square trinomial. So is 4 a perfect square? Yes. 25 is a perfect square. So we have 2z is our A, 5 is our B, and we need to know if 2 times A times B is going to be the middle term. So A is 2z, B is 5, 2 times A times B is 2 times 2z times 5, and that equals 20z. And 20z is our middle term, so it works. We can use the formula. That means it's just going to be A plus B squared, where we found that A is 2z and B is 5. And don't forget to write the 3z in your answer, because that's the common factor. This has to show up in your answer. And that is a summary of section 14.5. I should say that you can do the perfect square trinomials without using this formula, but I advise you to take the time to learn and practice the formula. It will save you a lot of grief, and you will be using it in 310.